Tariff meters. After the generator, the second most important part of the power station is tariff metering system because it converts produced energy into money, allowing the plant to invoice and get paid. If the produced energy is not measured correctly, it cannot be settled correctly. If it cannot be settled correctly, it cannot be invoiced. At that point, all effort invested in operating the plant does not result in revenue. In many power stations, tariff meters installed in the 1990s and early 2000s are still in operation. At the time of installation, they fulfilled their role. Today, they are difficult to calibrate, hard to maintain, and often no longer supported by the manufacturer. Spare parts are unavailable and replacement becomes necessary. Replacing tariff meters introduces a new challenge. Modern meters are using different protocols, different addressing, and different communication methods. They do not match what existing control systems were originally designed to accept. Direct integration would require changes to the DCS or SCADA systems, which is usually not acceptable. On this picture, we can see communication gateway to TXP system. At the same time, the most primary equipment can remain unchanged. Current transformers and voltage transformers are still suitable and continue to provide correct signals. The issue is not the measurement itself, but how the data is communicated. To bridge this gap, a gateway is introduced between the new meters and existing control system. On one side, it communicates with the meters using their native protocols. On the other side, it presents the data in exactly the same way as accepted by the existing DCS or SCADA systems. From the control system point of view, nothing changes. No logic is modified and no engineering intervention is required. Once data is available in the gateway, it can be also used for reporting. In addition to feeding the control system, the same data can be prepared for reporting purposes and directly used by operators and commercial teams. Reporting output can be generated at the required intervals, whether minute-based, 6-minute-based, or according to the other contractual requirements, and opened directly in standard office tools. Physical integration is as just important as data integration. Existing wiring from current and voltage transformers is reused. The same signals are split and connected to the new meters. No changes to CT, VTs, field wirings are required. The calibration equipment, or let's say connector, stay absolutely untouched. Because tariff meters are part of revenue change, physical sealing is necessary. The design must ensure that no manipulation is possible, either by direct access to the meters or through communication interfaces. All revenue, seals and related components remain protected by physical seal. The gateway must be industrial grade and designed to fit into existing cabinets. It must operate reliably in power plant environment and be compact enough to be installed without requiring cabinet modifications. Standard industrial computers are used, built from off-the-shelf components. There is no vendor lock-in. Media converters and related components are standard industrial devices. And of course, you can't change all the meters at the same time. Therefore, the product or solution has to be future-proof. New additional meters and even some other equipment might be added by simply configuring Excel spreadsheet. Cybersecurity requirements are addressed by design. The gateway operates with strict firewall rules. Interfaces are closed by default. Isolation is enforced. Any connection towards the IT environment is controlled by unidirectional communication via data diode. This approach allows tariff metering systems to be modernized without changing the existing DCS or SCADA systems, without disturbing revenue critical wiring, and without putting the profitability of the plant at risk.